Thank you. Thanks, everyone. Thanks for joining. And sorry, I guess it's the last one, so everyone is a bit tired. I'm also, unfortunately. But yeah, basically, it's also a bit different slide, different presentation than the other one. In our case, it's more like just what we experienced in an industry, working in a project, in a production-ready project, in a specific sector. So what are the challenges we faced? So from just real experience, basically just the learning of it. So in the sovereign GenAI, productionization, this rack system, especially for the public sector. Also a bit disclaimer, it might be also a quite bit text-heavy slide, but I hope I can follow with everyone. And yeah, so a little bit of background. I am Touhidul, or Touhi, everyone calls me in short. I am working in Accenture almost 5 years as a GenAI solution engineer. Before that, I was also a student in Germany studying AI technology, and last 5 years mainly working with different projects in a different industry, from POC to MVP, doing production-ready system. Yeah, more trying to focusing more in the tech side, basically. Yeah, as a hobby, I also like to hike a bit. I think you can see from the picture. So also like to play around or yeah, doing some photography as a part of my personal life. So let's go to what's the main agenda of this topic, like what is sovereign GenAI, why we are doing sovereign GenAI, what did we build, a bit more technical overview, like what is our solution idea and what are the challenges and learning we have faced during the whole processes. First, why sovereign GenAI? Does anybody already know here already what is sovereign GenAI, or how many of you heard or worked on that? Okay, yeah. So yeah, so in short, like what is the definition of sovereign GenAI? Why we need sovereign GenAI? It's mainly the taking control over the whole life cycle of like infrastructure, data, and like the people. So instead of doing on the public cloud or private cloud where we don't have all the control over the aspect like infrastructure aspect, data aspect, model aspect, or the people who are working in this sovereign GenAI's main goal is to, as an organizational perspective, ability to building and deploying on their own control over the full life cycle. And we also talk about with the sovereign AI, sometimes sovereign cloud, because sovereign AI does not necessarily mean just only on-prem deployment. It could also be sovereign cloud, which basically the cloud infrastructure that also govern for specific organizational or national or local laws, and also make sure that the data security and compliance all follows the local regulations. In that regards, in practice, what does sovereignty mean for us? Like, so when you're doing a sovereign GenAI AI or GenAI development, like there's different aspects, like data sovereignty, in a way like where this data is generally stored, where it's coming from, when it's processed, where do we store this data, how do we have control over this data? When we talk about like prompts, like using the prompts or the outputs, how they are being continuously used or monitored, or where they are being stored. And also as well goes like the telemetry, like when you send a production system where they have lots of signal passing on, where they are being stored, where they are being sent, all this having the control over the data sovereignty. Same goes for the model sovereignty, like where's the origin of the model, what is the intellectual property, what kind of license this is, do we have also to access this model, even if it's, let's say, developed somewhere in France or US, if we deploy it on our own infrastructure, can we actually use that? Then goes for if we can actually further develop this model or fine-tune this model or framework which we work with these models with, do we have all the further access to use it for our specific use case? Then comes to the model value, like even if we train the model or do not train the model, use a pre-trained model, what is the output we are getting? Does this model align with our governance or the ethics and everything? Same for the operational sovereignty, mainly like where do actually these models are deployed? How are we deploying it? Like, is it just our people? Is it somewhere inside our own infrastructure? Which kind of tool do we use? And mainly what is the performance reliability compared to the private cloud or public cloud, where we can generally use just like an API-based system. Also the operational effort, like how long does it take to work with this kind of deployment strategy on the on-prem or sovereign system. In the end, in the data model operation, all works, but in the end, if the user does not accept that, so that's another part is like the customer perception. Even if we do everything on the own control, how the user accept this kind of usage, if does it follow the responsible AI's guidelines, or let's say UAI clause, ethics, everything. Also, throughout the whole process, does it actually explain and trace all the processes in the life cycle? So in practice, we saw like these are few aspects that make sense that we need to consider when we're using or when we're trying to delivering these kind of solutions. So next we go a bit more like what we are required and what we build at a glance. So we have a problem statement, like we have a legacy software from different departments of a public sector where this software is different. This software is being digitalized into one custom software that has a different documentation. So user needs to navigate through all of this documentation to navigate the software. So in the end, from different departments, it comes to the like one software. So it's difficult to navigate for one user to understand like how to use this software or how to navigate without checking the lots of manuals or help desk to ask for the solution. So our goal is one of the easy solution at that time is just to making a conversational AI agent. So basically, just we'll have a chatbot that can help the user answer with this documentation or how to navigate this software. So, and idea is that also this internal software can be accurate and contextual and always updated if the software is being updated, so the user is also up to date with the latest answers. And one of the goals at that time was also to build on the state-of-the-art technology with the open source stack for sovereign GenAI cases, and it was also required for like air gap proportion, so like no internet access to the whole infrastructure anywhere. So that is one of the main goals. But the challenge comes like the software is being developed, but it's a software is being developed, but it's not for AI software. So at that time, there's like no like AI ready tech or organizational infrastructure was available. It's mainly everything was from scratch in that time. And since it was already being developed software, so there's lots of like data is rapidly growing, and so it's always difficult to catching up with the new data to update this and to also make sure that user is always getting the new information. And one of the main challenges is part of the public service system, like the on-premise system constraint is one of the main requirement. So how we build it just in a glance is like generally when we have this kind of project requirement, it goes to different phases. At first we get the requirement, we start as like a POC development, so very vanilla RAG chatbot developed with some just the on-prem infrastructure in one of the sovereign cloud and just basic front end. So the goal is to check the capability if the RAG solution can or this solution actually can be feasible in further usage. And once the POC is built, it's mainly validated by the queue and the domain experts just to check if it's accepted to go for the production phases. In the production phase, basically the main challenges comes around like, okay, we have a small POC, but how to make it to production so user can already work on that. So there should be some base stability, like production proper infrastructure and the backend that needs to be set up for production-ready app, as well as some basic functionalities like guardrails, authorization, proper ingestion strategy, regular evaluation, documentation, so it can be delivered as a production-ready application. In that period, we basically learn through like what are the important aspects that could be required for the solution for the scaling up as well. So this is more like one of our learning phases in here happens. And then it goes mainly the maintenance support where user is continuously checking, user is giving some feedback. Based on that feedback, we're trying to improve the solutions. And also like regular data update, if some bug fix, if some feature update, like guardrail enhancement, like that. Currently, it's kind of in a phase like where we are trying to scale it up for like one department to multiple department to one state to multiple states. So more like scaling up and scaling out in a different, on the same architecture. Next, we go through a bit more like the technology overview, what we did so far. Does anyone already work with the open source technology here? Okay, that's nice. Yeah, I mean, in our cases, we are also quite new when we started this one, so that went quite a bit of learning phase for us. So just as in very first beginning, like what are the main aspect we needed to clarify when we started this GenAI project. So when you're talking about like on-prem solution, first thing was like how we start with this. Like we have a use case like RAG for, we know what kind of model do we need, what hardware do we need, what serving engine do we need. So we need to clarify upfront these three aspects. Like I'll go to like one by one. Like the first, the model is depending on the use cases. Of course, in the RAG we know like LLM and embedded is the most use case. Sometimes we use re-ranker as well. It could be some other classification model depending on that. Sources, yeah, for the open source, of course, the best option is the Hugging Face. Hugging Face repository, basically the model repository. In case you also don't know, there's a like nice leaderboards for different types of tasks, different functionalities there. You can filter on like what kind of open models you want to choose on. So that's a good way to start on. And then there's like trade-off, like if I want for my specific use case, do I want a general purpose model, or do I want some domain or language specific model, or what is the model size we need? Do we also need to take care about the latency? For example, in a chatbot, latency is important. Or do we want a full model, full precision model, or does it work for a quantized model? So different kind of decision factor it needs to consider when deciding like what kind of model we want to choose for our specific project. For our cases, we have a very German heavy data, so we use one of the German fine-tuned Mistral Nemo model just as a pre-trained model, and Snowflake embedder, which is also one of the nice multilingual embedding model. Then comes the hardware part. Basically, it's also a bit dependent on the model. Like if we choose like we need a really big model, or we have a small model, so model size have a big factor, along with the like what precision do we need, if we need multiple concurrency. So these are the different decision factor. And yeah, there's NVIDIA, Intel, AMD, or many other kind of like brands, and their different models are available. And trade-offs also comes with the like the throughput, like how fast do you need this output, and cost and the power. Basically, nowadays the model size is getting like different models are coming on, and cost is becoming lower, but there's always a cost, power, throughput trade-off. And in the end, if we want to go for a like scaling up or scale out for future, that's also something to look into. In our case, we had like 3 models, so we used to like we had some 4V100 NVIDIA GPU, which worked well in our case for a early stage, but in future it could change depending on the user base we will have. And then comes the serving engine. Basically, when we have this model, when we have this hardware, how do we want to run this? In the cloud, we don't need to worry about that, but in the on-prem solution, like there's different tools. Like if someone is from the NVIDIA enterprise license, they can use NVIDIA Triton, or open source like VLLM, or Hugging Face's text generation inference, or text embedding inferences, or there's some lightweight option like Olama. That's also quite good too, easy to try on. And trade-off is if someone has the enterprise support, if someone does not have, then like open source options or some lightweight to try on first for like a small cases. In our case, we used VLLM and text embedding inference. That worked so far quite good currently. But yeah, the main core stack is like everything in the in our case, we had to use like the open source solution, and the sovereignty had to build around that. So I'll go a bit more in the like the technical overview, but not too detailed, because some part we talk about later phases, but mainly like just to give a flavor. Like we have this CI/CD part and the infrastructure part. So infrastructure is built on everything like different tools like model containers, database, and the monitoring tool. All are built upon the infrastructure. And then we had like a typical strategy, like from the source control, we get the code, we check, we use a CI/CD for Jenkins, and then code check with the SonarQube, and then everything is deployed on the infrastructure, like the ingestion part and the backend part. Once the infrastructure, everything is set up, then basically we can see like this dash arrow for the ingestion part, where 5 steps like A to E, which shows like what are the defined ingestion steps. In our case, we had some data coming from Jira and Confluence data sources, and they are being ingested to with the ingestion job in the ingestion container. In our case, since we have to also consider like a regular interval ingestion strategy, so we use like some Kubernetes jobs to regular interval. And yeah, once this ingestion Jira data or Confluence data is ingested to the container, it take advantage of the embedder and the LLM model to create the metadata and the embedding data. Then it goes to the embedding, like the vector database, in this case Postgres SQL, PG vector, and everything is also monitored towards like the different monitoring tools like Elasticsearch or Grafana, Prometheus, and as well also use some tools like Langfuse or DeepL mainly for like LLM traces or like evaluation. We'll go more in detail about the ingestion strategy and the tools I mentioned. And then once the ingestion step is done, the data is there in the database. Basically, from the front-end side, user can ask for the question regarding anything regarding the chat. In the backend, it goes to the question, and then it takes to the embedder LLM and re-anchor to make use in the RAG how we use different approaches, and then gets to from the database to get similar documents, and LLM basically respond that. And also everything's connected to the monitoring tool, so everything should be monitored and traced. So at least if there's any cases, we can always trace down. Similarly, we also use the Langfuse in here for LLM tracing and for prompt versioning as well. Ingestion and the backend part, we'll go a bit more detail in the next 2 slides. Just in case, yeah. So just quickly give a touch like what is the ingestion process. It's a typical RAG process, but in the RAG approach, what we do, but mainly that we have a ingestion as in like a regular jobs. So data extraction, first part is the data is coming from different sources, Confluence and Jira, which have a different varieties of data. So some are automated, some are using like manual export right now. Maybe in future we do it automated. And then we do some pre-processing like a regular text pre-processing, cleaning, normalizing text, restructuring in a specific format. And also then quality check, like if the data is complete, if there's any formatting issue or not. The next phase is like from the POC to when we went into the production, we found that there's some way we could also enrich the data, basically like creating some summaries of what currently we have the Jira stories and create some other metadata, which also helped to filter out. Later on, we saw how the performance evolved around if we had some further data or metadata. And once this pre-processing step or the LLM enrichment step is done, we went to the embedding, like chunking the data, pre-processing the data, and converting, and then goes to the storing to the database, the vector DB. And everything is also traced back in our case, we use Langfuse to step tracing, and all the steps is also monitored via the monitoring tools to check all the ingestion end-to-end processes. Next, we go to like what we did in our backend RAG processes. So once the ingestion part is done, we have the backend phase where standard RAG, in the vanilla RAG, what we have like the embedder, retriever, and the responses. In this case, it changes a bit like when we had the production phases, a lot of emphasis on the guardrail part because open model can be acted a different way. So we also need to make sure that we don't want any unwanted output in this case. So first phase is start as in like a input guardrail. In this case, like whatever input we get, we kind of validate and checked by a guardrail. So we started as like a LLM-based guardrail which is just as a start. Like LLMs tries to filter out some specific prompt with some specific prompt. Like if we don't want this approaches or if we don't want this kind of text, we just filter them out. And once they are passed, it just goes to the next downstream query per task. We'll talk another slide about guardrail as well. So once the guardrail part is done, basically we send to the query prep. In here we have task-specific, some action is happening, but these are all like what we found during our development phases that this helps to improve some extent like multi-query expansion. So when we have some complex query, we try to make it to compose in different smaller queries, or we use some kind of synonyms of the same query so we can retrieve more relevant or similar chunks which are also could be higher relevant. We have some action type classification which is more like task specific, like what kind of query it is. It just to filter out later on, and based upon like we have a Confluence and Jira data, but we also have like within that some kind of like different types of data. So we differentiate like some sources, like in Confluence, we have 3 types of sources. In Jira, we have 2 types of. Then, based upon the query, we just try to give some relevance score, like which query makes more sense for this, which data could be more, which data source could be make more sense for this kind of query. So just like some relevance scoring. And in the end, once we have the query prepped, everything, we just send it to the embedder to embed the queries. In the retrieval phases, mainly, at first we try to generate as a retrieve like a high level, like we did some summary, just getting some like high level data, and from that we then pass to the different contextual, like different data sources, and retrieve information out of that. And we also have some glossary data. Mainly we use some keyword and keyword search to retrieve those from the glossary. In the end, we have a different data sources, and there are some relevant chunks, and then we use some filter based on the filter metadata we have, and then use a re-ranker model, which also helps to get all the data and try to make another shuffle of ranking of these based on the query mainly. And in the end, once we have this in all the informations, then we send to the LLM the context information, the query, and the chat history, and that sends stream the response to the that LLM sends the response and stream it to the user back. And again, all the phases, we are basically using some observability tool to make sure that everything can be tracked and everything can be properly, if something goes wrong, everything can be traced back to what is going on. And we also have some matrices, like how long does it take, or what is the input and output token size, just for our development understanding. So once we have this rec process, then we want to also talk about, like, we did not start with evaluation, but when we are doing the production phases, we saw this is one of the important aspects that helped us to enable development faster, and also now we kind of use it like a regular automated evaluation. So why this matters is that we started as in like an LLM as you judge steps, like intermediate steps to evaluate the system during the development phases. So basically, when you're enabling a new feature, or when you're trying to change something, how do you make sure that nothing goes completely backtracked or some other way it doesn't go wrong? So we always had this evaluation to check if it's currently in the right track or not. Consistently quality gating before the prod injection right now, because once we have the development phase is done, every time we have a new data or every time we have some changes before going to the prod injection, it's always evaluating the same way. So just to make sure everything on the right track. And yeah, again, I think we talked about a lot about Langfuse, but in this case, Langfuse also helped us through showing the dashboard for tracing, visualization, also the analysis. And the steps-wise, basically now what has happened is that every time we have a new data there's a new releases, new data is being ingested, we run the evaluation script. We use depeval as kind of like a framework, but it could be any other frameworks as well. We have some we have some matrices. We also have some LLM-based matrices just to keep track, like everything is on the order, or like the answer or the context information. And yeah, we trace it Langfuse and analyze and document back. This is one part that like we do it from our end, but also like once we have the system, there's always like the user feedback user is giving, and we can check in the Langfuse, and that's like in a loop, continuously monitoring and iterative way try to improve this. So once the evaluation, mainly the last topic was also want to talk about like the guardrail and safety. So we did not have the guardrail in the pre-phase, like the POC phase initially. Then we had lots of comment regarding model can be giving any types of output, even as in like a RAG-based system if it's properly controlled. So initially the case was just to give some control over some certain aspect, like filtering something, like filtering jokes. So we don't want to use it as a tool to generate joke, or talking about like politics or impersonation or some unsafe query that should not be passed into. And also like some rule-based control we provided also via the prompt. Basically no code execution should be done, no system prompt reveal should be done. But these are more like way to using prompt, but at that time probably not the best way, but it's always a ongoing topic with the guardrail, because every time new model comes on and there's some jailbreak strategy, it's always difficult to provide a proper active solution. But we also have some other like moderation layer to make sure that the model does not take an input like offensive or like inappropriate output, and it's like the feedback integration. It's incorporating also the user and continuously trying to evaluate based on the user feedback. So that was in our phase that was done. Currently, we are also trying to solve some other. So we saw like there's many models available, many data sets available, which also increase to evaluate the jailbreak example. For example, many jailbreak data set helps to understand like which data kind of jailbreak can be jailbroken in our model. So this way to understand, so our system can be properly guardrailed with jailbreak defense. Also, model can also sometimes generate markdown on code if given some certain way, some prompt. So those also currently trying to solve that. It's actually at least provide like some safe formatting without any execution. Also some output guardrails. So when I try to put some output before sending to the user, just to make sure at another layer that every output is validated and filtered. And currently we're also trying to more like automated evil-driven guardrail checks. So it's an ongoing topic, and it's going to be long-term ongoing topic, because this is one of the crucial factor before and after from the user side, getting that after sending that query and before getting the responses, we needed to make sure guardrail works safely. That was from our application side, but we also had like a more in a outside the application, like we had a AI security framework, basically assessing like AI risk management, model security, like how models are secured, which licenses do we use on, do we have the proper permit, how these data are trained on, do we have any like the digital identity apps, infra security, data security. This is more like some checklists we need to also go through or follow through, like the EU AI Act law, GDPR law. So everything had to go through in this checklist, just to make sure, especially in the public sector, it's very crucial to follow these kind of regulations. So that's the main topics, and then we just quickly go through like what are our learning phase throughout the whole development of these spaces. So main ideas that we had to build through everything, like the on-prem based system, from the architecture and also to the adaptation of organizational adaptation, also technical adaptation. From the technical side, we went through like the POC to the product first, like our rack evolution, like shifted from vanilla rack to the hybrid pipelines or hybrid search rack as well, or like stronger grounding, and it had higher maintenance support, but in the end we saw the performance have been accepted more, or it has been more user accepted and sufficient. We also went through like different data strategy. Like initially we had a bit of like data chaos, data coming from different places. We did not know too much like what's the good data or what's the bad data. Then we also had some data enrichment with LLMs, or also some team is also helping towards creating some good data. We in the end saw that helped our evaluation approaches throughout the phases. And as mentioned, evaluation is, we learned that throughout the automated evaluation, it helped a lot nowadays to, before every release, to check the consistency. Any new information is added, that also quietly helping us throughout the processes. And guardrail, currently we have like more like domain-specific filters and basically aligning with the security and responsible AI, but it took quite effort, and it's going to be always an ongoing process, because there's no absolute solution right now for guardrailing, because every time new models comes on, there will be some way to jailbreak, some way to get past through it. From the organizational perspective, yeah, initially there's like lots of expectation, like everyone wants something like ChatGPT on their own, but in the end it's a niche domain, in the end it's a specific problem trying to solve. So that was one of the early expectation reality cases, like, yeah, we are not using that much of hardware or data center like to have own solution, also like general knowledge, but that was also understandable at some extent. And inference cost, mainly nowadays models are being smaller, and GPU costs are also slightly going down because better GPUs are coming on. But in the end, we saw it for a long run perspective, it saved times and cost a bit, because if we think about like long-term perspective, if this architecture going down, then going to be working on, then we just have the same GPU or just scaling up, not like any public car or the API-based costing we don't have. So for on-prem perspective, it's kind of going towards that way. cross team, yeah, it was quite new for everyone, like even in our team, like the other team who are working in the DevOps, for the model and data updates, always a challenge because every time there's new models, so maybe they have a new architecture or there's new data changes. So it requires a close collaboration between different teams just to everyone understand what this architecture technologies, how we are going to work on. And main last one is the adaptation to change. This field is going quite fast. Like every day there's a model, there's a different model coming on. Libraries are going so fast that if we are using one certain library and it gets broken in the second day, so we always have to make sure that which version we are using, and it's become quite everyday's challenge to frequent model or library updates. So, but with the proper design and the fast re-evaluation loops, it's quite understanding we should adapt to these changes. So mainly the final takeaway, like in the RAG solution, mainly it's not just about getting the answer for us. It was also to make sure that we get the relevant answer, we get the reliable answer. So at least we evaluate everything, we give the proper output, and of course we're responsible for all the throughout the processes, like input to output, and to make sure the whole end-to-end system is safe and secure. Architecture design, we found like initially it was a quite crucial factor when you start something with on-prem. Once we know what kind of architecture we design, and then we can always scale it up or scale up or scale out to make sure that this architecture, like this model, this hardware, or this serving engine will be useful for future long-term perspective. And starting evaluation early was one of our observations. Like nowadays, any project will start with the kind of evaluation as long as we have the data. It's better to start evaluation to make sure that we can find problems than later when it's already in production. And security guardrails are nowadays not just for the public sector, but any sector is kind of crucial, especially in the open space, like the open domain, since we don't know what data models are trained on. Like they are not always public, so it can be generate any kind of stuff. So we need to just make sure that it's properly guardrailed. And we saw it from any other talks, like there's lots of talking about agent automation. I think this is also kind of like the base of the future. And with the sovereign GenAI and the sovereign field, we also see like with this architecture, with this strategy, it's also going for the future. Sovereign GenAI agentic automation is also going to be part of it. In that regards, that's mostly my talk. Yeah, thank you.
Thank you, Touhidul, for your speech. We have a question here. So how long did the project take, and how large was the delivery team in terms of FTEs?
We have different phases. For the POC phase, it was generally, POC phase can be very small, 1 to 2 months, but in our case, it was 3 months, also 3 FTEs, because that time it was quite new for us with this on-prem strategy and on-prem architecture. We had to understand like what are the problem statement from even the client perspective, and how we're going to solve it. So we tried to do some like research, like what architecture we're going to use, what model going to use. So initially that was 3 months for the POC phases. Then for the production phase, we went around 5 months with 3 full-time FTE. Also like that time we had the base already. Mainly we needed was making the production ready, making the code stable, making with the existing software to include that. And from that on, it's like, it's an always approach now. Like it's not ending project right now, because it's always doing improvement, doing maintenance, and trying for new features. Yeah. So.
All right. So anybody else from the audience? Any questions? Okay, we have another question. So in a slide, what test methodology steps were implemented to ensure correctness of the produced outputs of the whole solution?
So during the processes, we had like, one is code-based wise, like we had all the unit tests, all the integration tests from our coding perspective, but also for the output of the actual RAG responses, we had one is first like the LLM-based evaluation for our evaluation, but then also like some contextual evaluation, like if we are getting correct context. So some matrices we use like how much accurate these contexts are according to the provided context. So we had the data set. That was actually good. Like during the process, we also get some data set available. Without the data set, it would have been difficult to produce this result because then we are out of nowhere, basically. Yeah.
Okay, so next question. Was whole infrastructure on-prem, including apps?
Everything was on-prem. Like we are kind of forced to, like, it has to be air-gapped solution. Like there's no internet going on. So we just had to get the models first time from the Hugging Face, and then like the libraries, of course, we have to get this, but then the whole development infrastructure, everything was in the on-prem solution. Like I already showed in the diagram, like what are the main frameworks, main tools we used, had to be everything on-prem.
Okay. Thank you. So thank you, Touhidul, for the presentation.